Hello everyone, welcome to MBAtrek. Welcome to the Aptitude Bootcamp by MBAtrek Private Limited. I welcome each and every one of you, whoever is with us on this Zoom call, and whoever they are with us on YouTube Live. We welcome each and every one of you in this Aptitude Bootcamp, and we hope that by the time the bootcamp is over, you leave with a lot of gyan, a lot of tricks, and a lot of methods to help you ace your placement journeys, your aptitude test, your campus placements, off campus placements, and so on. We will just wait for, let's say, another couple of minutes to ensure that people have joined us on Zoom call, and then we will continue with the thrilling journey that we have planned for you. By the way, if you have any questions, you can put it here on what's on YouTube Live. You can put it here on Zoom call, right? And we will be very happy to answer the very same. So people are coming right now, and let's continue. If there is anyone who joins, we will take them in the journey all together, right? I once again welcome each and every one of you to this aptitude bootcamp session. So let us start with the basic introduction. But before that, what we have for you in this aptitude bootcamp, right? Yes. Okay. So first of all, what this bootcamp is all about, what this 2-day bootcamp is going to offer you, all right, in terms of quizzes, in terms of content, and in terms of learnings. Okay. So a lot of you who registered in this pre-bootcamp quiz would have got an email around, let's say the pre-bootcamp quiz that was supposed to be conducted. And for those who have not attempted this quiz, and for those who have not really registered into this boot camp but are watching us on YouTube Live, so there is an opportunity to win a lot of things if you attempt these pre-bootcamp quizzes and post-bootcamp quizzes. Okay, and in the middle of these two, we have a 2 days bootcamp tightly packed for you, full of learnings. All right, now once we are done with this bootcamp, so basically, yeah, to help you understand what this pre-bootcamp quiz is, so this is what it is. Just go to our website mbatrek.com, sign up, verify your account and log in, and click on this link, mbatrek.com/aptitude pre-bootcamp quiz. Okay, just go to this assessment, use this coupon code pre100. Okay, use this coupon code pre100 to unlock this pre-bootcamp quiz at free of cost. Okay, and the better you score, the better are your chances to ensure that you get a cash prize and you get multiple scholarships that are associated with our trip to placement program. Okay, let's continue forward. So yeah, I already told you about a lot of rewards that are associated with this bootcamp, but just let me tell you once again. So the top 3 students who have the cumulative highest score in the pre-bootcamp quiz and post bootcamp quiz will get cash prizes of rupees 1500 to top 3 students. Other than that, we are coming with a very unique program, that is prep to placement. It is something which we believe, has been missing in the market, which after a lot of survey and after a lot of interaction, with students like you, we came to know that there is a need of a program to take care of not, just live classes, not just self-paced courses, okay, but there is a need of one-to-one mentoring to help you ace and, ace in your placement journey and get a right job, not just a job. Okay. So this is a program we are going to launch in the month of April. And the students who happen to attempt very well, in these pre and post quizzes will get scholarships on those programs as well. At the end, definitely MBAtrek is known for a lot of things. And in the near time, we have sponsored a lot of campuses, 10 to 15 campuses at least in past couple of months across the across the country. So definitely we are going to provide you with free MBAtrek products and services, whoever is a part of this boot camp. All right. Now, so what I'll do is, I'll be very happy if you can tell me, in the chat box, be it in the YouTube live or be it, here in the Zoom call, that which of these topics, you find, most difficult. You can select one, two, whatsoever, right? So just let us know in the chat box over here. Just let us know, um, you know, uh, in the YouTube live, that which of these topics do you find really difficult and which of these topics do you want, us to guide you on in addition to what we have already planned. All right. So I'll just, wait for your responses, in the chat box. Yeah. So people say they find difficulty or, they want to be guided on permutation combination. Well, everyone wants to be guided on those topics, PNC, probability, data interpretation. Okay. Someone also said, interest and geometry and mensuration, time, speed, distance. Okay. Interest, permutation, combination, again PNC. And I'll be very happy, if all of you can participate. See, because this is for you. This boot camp is to help you, right? Ace your placement journeys, ace your you know get a right job altogether. Okay. Okay. So more or less the responses, are more or less same. It's PNC, it's data interpretation, it's other things as well. Okay. So perfect, perfect. uh, NVR. Okay, can you please, tell us full form of, what you actually, supposed to say when you say NVR? Okay. Uh, all right, all right. Okay, non-verbal reasoning. Okay, yeah, I totally got your point. So that is, again, a very unique zone, I should say, because verbal reasoning is something which a lot of people understand, right? You have a lot of a lot of subtopics there, but when it comes to non-verbal, students do face difficulty. So it's okay. uh, all right, all right. I think, we have got enough responses to take this journey forward, to take this webinar, bootcamp forward. Okay. So a lot of you told about, I'll just, frame few general topics, common topics. It was data interpretation, it was PNC. Okay. And it was time, speed, distance, reasoning and all. And this is something, which we are definitely going to cover in this 2 days journey of a, 2 day bootcamp. Okay. So now, let us tell you what we are going to cover today and what we will be covering tomorrow. And yes, since, I have asked questions around what you need, for yourself, definitely I'll come with some different content that I had planned for tomorrow, along with what you told me to. Okay. So today we are going to cover these four things. Okay. The four Qs of PNC. Okay. The four quadrants of PNC is, that is what it is, by the way. We are going to cover 8-box formula. So we are going to see 8 boxes in which, we will have formulas and we will understand when to use what. Okay. We will understand the trick of a very simple topic, but still very effective. That is the multiplier. Okay. And finally, we are going to see a trick of LCM, through which we can make trees and help, and solve problems of time, speed, distance, and time and work, and how a simple and a very unique trick, which involves ratio, would be able to help you solve a couple of problems as well. Okay, so this is what we have planned for today. Now, for tomorrow, what do we have for you? Obviously, we have round and round and round. So we are, we are going to be talking about circular arrangements. We are going to be talking about setting problems. So things like that, okay, in which we have, circular approach, that is to be applied. We have Kyabe theorem. So that is basically Bayes theorem, we are talking about, because a lot of students, they find difficulty in understanding that when do we have to use conditional probability, when do we have to use multiplication theorem, and when do we have to use Bayes theorem, total probability. So there is a lot of, confusion around that. But don't worry, that is something which we will sort, not today, tomorrow. Okay, so a funny name that we have given to it, Kyabe theorem. Okay, finally, we will move on to the only X, you can trust. So we are talking about the X method, by which, you can easily solve the problems of mixed sets and allocations. And it is also applicable in solving problems of profit, loss, and discount. Okay. And finally, at the end, we will move to, interview puzzles. Okay. So common interview puzzles, that an interviewer might ask you. So see, we have a lot of people, who would be watching us right now, who are in this meeting right now. They could be from engineering background. They could be from, okay, you want me to be a little louder? Okay. uh, okay. I'm really sorry for that. I hope, I am audible to you now. Is that okay? Can I just get a yes in the chat box? Okay, okay. Thank you so much, Naveen. All right. So we are going to, encounter few interview puzzles, that are very common, but still, that are anyway asked, in interviews to check your critical thinking skills, problem solving skills, and so on. And obviously, in both these days, at the end, we will have a Q&A round, okay, in which we will listen to your queries. We will help you resolve your queries as such. Okay. The session is going to be, maximum 1.5 hours. I'll try to wind up, in the lesser time possible. But what I will not do is just run through the concepts. See, because that is one of the core reasons you are here with us, right? A lot of these things are already available, on multiple channels, on multiple platforms, but still you are here with us, right? Why? Because you are not really satisfied with either those concepts, those explanations, or you want someone to actually sit along with you, take time with you, and guide you. Okay. And that is what, we are doing here at, as MBAtrek. Okay. So let's take this forward. Now, before I talk about, and before we actually jump into the content that we have planned for today. Okay. Just a second. Yeah. So before, we actually jump into the content that we have planned for today, let me, just give you a quick brief introduction about our company, MBAtrek. So we started our journey, in ideally, in December 2016. We have been into the market for past 3 to 4 years. And what we do is we help people like you, students. We help people, young professionals, to upskill themselves, be it in terms of, getting the right job, getting the right career opportunity, be it in terms of internships or placements. And how? By developing skills, by not mugging few concepts, by personalized one-to-one mentoring. That is what we actually do, we have been doing. And that is what, the basic motto of our company is. So we with that, let me introduce you to the founders of our organization. So we have Mr. Alok Shrivastava and Mr. Abhishek Shrivastava as, the two founders of our organization. They cumulatively have around 55 years of experience altogether, and you can easily see the industries, the companies that they represent and that they have represented in the, in their career. Okay. So, a basic introduction about, what MBAtrek is and what it does. Just like I said, it helps, students like you, whichever institute or university you are a part of, and help you launch your careers in organizations like these. Okay. And that is something which we have already done for students in the past. Okay. We have helped them ace their internships, aptitude rounds, group discussions. We have helped them along a lot of verticals, right? So that is something which we do. Okay. Now, before we actually, just the last thing about myself. So you should be knowing, who is mentoring you, who is taking a webinar. So I am Ayush Mittal. Hello, everyone. I'm currently working at MBAtrek as a product and business development manager. Okay. Before that, I worked in one of the organizations of Quota via certification as an assistant general manager. I totally have 3 years of work experience in the education industry and prominently in startups, wherein I have worked across a lot of domains, like you can see sales, marketing, product operations, and others as well. I have done my engineering in computer science and I have done my MBA from IIM Kashipur. And in my career of 3 years, I have mentored and trained almost 1,000 plus students from multiple IIMs, from multiple IITs, Kanpur, Madras, from BITS, and helped them get their jobs in companies like Amazon, TCS, Accenture, amongst others. Okay, so that is a quick, 1 minute introduction about me. All right. So I am pretty much excited, to take your journey forward, because what comes next is something I believe and I hope that is going to be unique in a couple of ways, that you're going to learn something new, something different. My objective is not to tell you which formula to apply, not just limited to that particular thing. My basic vision, even I have a vision for this webinar, just like you. And my vision for this webinar is to help you visualize problems, not just write it, by throwing in the formulas or the numbers that are given over there. Okay, and that is something which I'll try my best to help you with. Okay, so let's take this forward, and finally, let's begin. Yeah. So first of all, let's talk about, before we talk about anything else, let's talk about how the placements look like. Okay, because that is something which is really very, very important to understand. Okay, so, and the order in which I have mentioned these could be up down. So there are companies which sometimes take HR interviews first. Okay, there are companies which do not take any GD or a written or a case based process. Again, there are companies which might take your aptitude test first and then talk about profile shortlisting and so on. So in general, this process will vary from company to company, right? But more or less what it looks like. So there is going to be what, a profile shortlisting thing. Okay, and yeah, so there is going to be a profile shortlisting. So for that, you have to have a very good resume, a very good present. Resume is very, very important in terms of profile shortlisting. So is these days LinkedIn. Okay, so this is also equally important. Okay, all right. Now once that is done, you need to clear the aptitude test. Okay, and the level also will vary from company to company, but more or less it's not very difficult. Definitely is nowhere going to be around cat, zat, snap or so on, but definitely it's not very easy also. Okay, and that is why you are into this program, right, to help someone guide you along this. Okay, so then we have, in few of the organizations, we have your GD or written assignment or a case that you have to solve. Finally, when it comes to engineering, you might have a technical interview, okay, or a technical test in which you might be you might be thrown by multiple code competitions, coding competitions. And even in management, even in BCom, BBA, you do have technical interviews, okay, around the academic concepts, right? And finally, we have HR round or final interview. Okay, so again, what I said, the sequence can can differ from company to company, but more or less, if I have to say that the things you should be taking care of, these are the few things. And finally, this is what the placement funnel looks like, because at the end, after every round, a few of the students are going to be shortlisted, a few of the students are going to be rejected. Okay, so that is something which looks like. And our only mission should be to go from enter this funnel from here and exit it right from here, right? And that is what every one of us wants to happen someday, okay, in our career journeys, right? Okay, so, and talking about this this boot camp particularly, we would be talking about aptitude test in general. Okay, and also to let you know, if you are interested in getting few very crisp and clear points about your profile shortlisting, about your interview rounds, be it HR or technical, we have another bootcamp for you scheduled on Wednesday and Thursday. That is the Grad Explore Bootcamp. Okay, what you can do is, obviously after this webinar, okay, just go to the Dare to Compete page. Okay, what we will do is we will also send you the link of the very same, right? And you can register yourself in that particular webinar also, okay, in that particular bootcamp, right? Okay, enough said. Let's take this forward. So yeah, Okay, so let's start the journey with the very first thing, the four quadrants of permutation and combination, right? Okay. Now, the reason, what is the reason that I have picked this topic, okay, as the first one or as one of the topics to be taken in this bootcamp? The reason is very simple. So before my MBA, I used to teach students for these, competitive examinations, undergrad and postgrad in the management side, CAT, SNAP, and others. And this is the basic query which a lot of students had. Sir, what is permutation? What is combination, right? Where do we exactly use these formulas, NPR, NCR? In few of the cases, I have to divide, the answer by R factorial. When do we actually do it? What is the meaning of N factorial? Why, when and why do we use it? There are few questions in which we don't use formulas directly, but instead we make cases, right? So can you please tell me, when do I have to understand that, okay, in this particular scenario, I will use NPR or NCR. In this particular scenario, I'll, may probably divide by R factorial. And in this particular scenario, what I'll do is I'll make cases. This is something which is very important to understand, because a one pager, just Google for yourself permutation and combination formulas or permutation and combination tricks. There are a lot of websites which are doing a great job, by the way. Okay. And I'm really, really with them. But what I feel, because a one-to-one interaction or, interaction with the students is really very, very important. And after that interaction, not just me, a lot of trainers have realized that this is something which needs to be answered. Okay. And here we have the solution, okay, by drawing and helping you understand through the four quadrant thing, right? Okay. Now, and meanwhile, see, I'm very much open to doubts as well. If there is any, if you want me to stop, if you want me to go slow, if my voice is not audible, just let me know, let us know, and we will take care of it right away. Okay, perfect. So what the four quadrants of permutation and combination look like? You have to understand a couple of things, before we actually jump into these four quadrants. There is something which we have to maybe select or arrange. Okay. So basically permutation means arrangement. Okay. And the combination means selection, right? So those things can be different. Okay. So there could be three things, A, B, and C, or those things could be identical, right? So there could be two A's and one B. There could be all three A's, right? Or there could be two A's, two B's, and one C. So cases in which few of the things are identical and cases in which all things are different. Okay. Similarly, there are scenarios in which you might have to select or arrange all the elements that are given to you. Okay. Or you might not have to select or arrange all, but a few of them. All right. So that is again something which is, a differentiating thing. So for example, if I take ABC, there is a possibility that I might have to arrange all three of them. Okay. And there is a possibility that I have just two places left in which I have to arrange, two things out of these three. Okay. So you need to understand these two things. Very simple, right? Things could be different or things could be identical. Point number one. Okay. Point number two, we might have to deal with all the things or we might not have to deal with all the things. Point number two. Okay. Just remember, or, just look at the problem from these two angles and you will be able to solve it. Okay. Now, what happens if all things are different and we have to deal with all of them? Let's deal with this particular case. All right. So the answer, is something which is pretty evident. You can see on the screen, but let me help you. How exactly does it happen? Okay. So for example, there are three things with us, A, B, and C. We have to, let's say we have to arrange all of them. So if we have to arrange all of them, let us draw three spaces. Okay. Three blank spaces in which we have to arrange. At the first blank space, we have three options, right? It could be either A or B or C. Once we have, and it's totally up to you, whichever thing you pick, right? Whichever thing you pick for the first thing, for the second position, you would be left with only two options. Okay. So you could be left with A or B if you have selected C. Okay. At the first position, You could be left with B and C. You could B or C. If you are, if you are left with, if you have selected A at the first position, or you would be left with, what is left, A or C if you have selected B at the first position. Okay. Similarly, once you have filled both these two positions, you would have just one thing to be left, one thing left with you to be arranged at one place, right? So this is how you draw the numbers. Okay, 3, 2, 1. Similarly, if there were four things, you would have written 4, 3, 2, 1, right? Now, another important question: should we add it or should we multiply it? Okay, always remember, this particular thing. And is basically, when we multiply, and or is something in which we add. Okay, just ask yourself, in order to arrange these three things in these three places, do you have to arrange the first place, or arrange the second place, or arrange the third place? Or you have to, or can you say like this, that you have to arrange at first place, and also arrange at second place, and also arrange at third place? Once you do all these three things, only then you would be able to complete this assignment, right? What assignment? Of arranging three things in three places. Okay, so whenever we use the common word or, we have to multiply, right? And whenever we use, sorry, the common word and, right? And whenever we use or, we have to add, right? So as you can see, we have to do all these three things, right? So that is why we multiply, that is equal to 3 into 2 into 1, which is nothing else but 3 factorial. And here is your answer, n factorial. Okay, similarly for four things we have 4 factorial. Okay, so if you have to arrange, okay, if you have to arrange n different things, okay, and all of them, the answer is going to be n factorial, bottom line. Okay, but let's say if you have to select, no issues, let's say again we have three objects A, B and C. You have to select all of them. In how many ways can you do it? There is just one way. Okay, there is just one way of selecting all of them, and that is just select all of them. Okay, in in terms like this, it is 3C3, that is equal to 1. Okay, and that is why we have written 1 over here. All right, so this is something very very easy to start with, but yeah, it helps you understand what exactly is happening and how exactly should you be solving the problem. All right, okay, now let's move to the second quadrant, in which we have again all things different, but uh, there is a possibility that we do not have to deal with all of those things. In that case, what do we do? In that case, you use the basic formula that you have, NPR and NCR. Okay, given that there are no constraints. Okay, so if there is no constraint, just use the formulas accordingly. All right, so again, just to take this into consideration, if you have four things, A, B, C and D, and you have just two places, right? You have just two places. Maybe you will say, okay, at the first place I can arrange four things. Okay, there is a possibility of arranging one out of four things. Okay, and once that is done, there is a possibility of arranging one out of three things on the second place, and hereby the answer is 12, which is nothing else but 4 factorial by 2 factorial, which is equal to your NPR, 4C 4P2. All right, similarly, if I have to select two objects out of these four, what I'll do, I'll simply do 4C2, which is nothing else but 6 as your answer. And you can clearly see these 6 options are, it could be AB, it could be AC, it could be AD, it could be BC, BD, or CD. These are your 6 options. Okay. Uh, can you say that AB and BA are different? Yes, but when it is about arrangement, when it comes to selection, AB and BA are identical. Okay, that is again something which you should always remember. Okay, so talking about the second quadrant, if there are different things and you do not have to deal with all of them, so when it comes to permutation, just directly apply NPR, and when it comes to combination, just directly apply NCR. All right, Okay. Now let's move to the third quadrant over here. Okay. Perfect. And again, now we are dealing about, we are dealing with things in which we have identical things and we have to deal with all of them. Okay. We have to deal with all of them. Okay. So for example, let me pick this word economics. Okay. Let me pick this word economics, right? I'm given a question that how many words are possible using this word, economics, right? What I have to do, see what the problem is asking us to just arrange, all of these alphabets. Okay. But here we see that there are few alphabets which are identical. Okay. What are they? We have what? Two O's. Okay. And we have two C's. Do we have any other repetition as well? No, I don't think so. Okay. So how many alphabets do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So that is 9 factorial divided by whatever repetitions that you have. Okay. So you have 2 factorial over here and 2 factorial over here for O and for C. Okay. See, one thing that you have to remember, and please be, take precautions around that, that the answer is not 9 factorial by 4 factorial. This is not your answer, right? You have to understand, just a second. Yeah, you have to understand that, in the denominator, when we write something, we write individually for each and every word. Okay, not collectively. All right. And that is something which we have written here. Okay. Again, when it comes to selection, if we have to select all, it doesn't care. It doesn't matter. If the things are different or identical, the answer is going to be one. Pretty sure. Okay. So this is how, you understand that which formula to use where. You should never get confused. Okay. Should I be using NPR or NCR over here? You don't have to use anything, because if you are able to identify, are all of my things different or identical? Yes. Okay. This is the zone I have to deal with. Okay. Do I have to deal with all of the things, or, not all the things? Not all the things. Okay. This is the zone that I have to deal with. Am I talking about permutation or combination? Permutation. Here is my answer. Okay. Until and unless there are constraints. So there are problems. So for example, how many, let's say out of these alphabets, out of these numbers, sorry, 1, 2, 3, 4, 5, how many 4-digit numbers that you can select which are even? Okay. So here you have constraint that, at the last place. So what is an even number, by the way? It is something which ends with either 2, 4, 6, 8 or 0. Okay. Obviously we do not have 6, 8 or 0. So that is, out of the scope of this question, right? But what we do have are two numbers, two even numbers, 2 and 4. So obviously at the last option, we have to first of all deal with the constraints. Okay. So for the last option, we have two considerations. Okay. Now, once you have considered, be it 2, 4, whatsoever, you are left with another number along with three other numbers. Okay. Along with three other numbers. Okay. So 3 plus 1, you are left with 4 numbers. Okay. So now the answer is pretty simple. 4 options for the first possibility, for the first blank, 3 options for the second blank, 2 options for the third blank. Okay. And herein your answer goes 24 into 2, that is equal to 48. Okay. See, this is how you deal with these problems which have constraints in them. All right. Okay. I hope everyone is with me till this point of time, because what we are talking right now is pretty very simple, but we are talking about it in a structured way. We are trying to visualize the problem in terms of quadrants in order to help us understand which formula to use. Okay. So, okay, see Disha, the answer will be 1 in all identical if we are talking about combination. So the upper answer is for permutation, the below answer is for combination. Okay. So let's say there are, there is a case. So let's say, there is a case like we have 3 A's. Okay. We have 3 A's, all are identical. I have to select all of them. How many ways there are? There is just one way. All right. That I will select all of them. It's just one way. Okay. Similarly, if I have 2 A's and 2 B's and I have to select all of them, it doesn't really matter. right? The answer would still be just one way, that okay, select all of them all together, no other option. Okay, so that is when the answer, one comes. Okay, now let's talk about the case approach. Okay, it happens when a few of the elements are identical and we do not have to solve, I mean, we do not have to deal with all the elements. Okay, so that is when this particular case based approach, comes into play. And this is very important because this is something on which students generally, they feel a lot of problems, they get stuck. Okay, so this is which I would be doing by taking a real problem. Okay, all right. So let's look at this problem. There are 10 items in a bucket. What are those 10 items? We have one A, we have three B's, we have two C's, and we have four D's. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, we have 10 items in a bucket. In how many ways can we select or arrange four of them? Okay, so what we will be doing, in next 5 minutes or so, we will be talking about both the scenarios, permutation as well as combination. All right. Okay. And I'll try to go slow because this is really very, very important. Okay. So see, what do we mean when we say cases? Okay. Let us first of all try to understand those cases before we actually, before we actually start applying NPR or NCR or the general formulas as such. Okay. See, how many things you have to deal with? 4 out of 10. There are few things which are different and there are few things which are identical. All right. Okay. So, just do one thing, draw a table over here. Okay. Different and identical things. So what we are trying to do here, we are trying to, we are trying to create cases. All right. Now, your case number one, your case number one could be that all the four things that you select or arrange, okay, and whatever thing that you choose, be it selection, that is combination, or be it arrangement, let it be, just a second, yeah. So let us talk about that later, but first of all, let's talk about cases. Okay, so the first case is all four different. Okay, is there a possibility that it can happen? Yes. Okay, so the first case is all four different. Okay, let me just write it here as well. Okay, all four different. So let me also admit people, in the middle. Okay, all four different. Do we have four options? Yes, we do have four options: A, B, C, D. Okay, so don't repeat elements over here. Okay, when we make cases. Okay, so this case is possible, right? This case is possible. Is there a possibility that this case would not have been possible? Might be. If there was option like, if the question was like A 4, or let's say 5 times B, or 2 times C. Again, there are how many? 10 elements in a bucket. But now we cannot say that all four of them are different. So this case will get rejected in that particular scenario. But in this particular scenario, this case is accepted. Okay, right. So we have all four different options. Okay, and if we have to talk about selection, we are talking about four things out of which we have to select four options. Okay, so there is just one option to deal with, right? There is just one option that is possible, that just select all four options altogether. Okay, I'm right now talking about selection. Okay, I'll talk about arrangement after this, after once we have talked about selection. Okay, so this is the first case that is possible. Now let's talk about another case. Okay, so see, if I write three different and one identical, that will not make sense, right? Because for anything to be identical, you should have two things with you, right? Only then you can say that, okay, these two things are identical. Can you ever say that one thing is identical to what? To a second thing? No, right? So this is not a possibility, and this is never going to be in any of the scenarios, right? So the second possibility is two different, okay, and two things identical which are of the same type. Okay, so let me just take the second case: two different and two identical. Okay, now when we talk, always talk about the constraints first. So the constraint would be on identical, Why? Because A is not identical, right? So for identical, we have three options, B, C, D. Okay. For identical, we have two options, B, C, and D. And out of these three options, we can select only one. Okay, we can select only one. Why not two? Here, here we have written two because we can select only one, of which we will select both of them. Okay, so we can select either B, so that will make B B. We can select, or we can select C, so that will eventually make C C, and similarly for D. Okay, so we can select one out of these three options in 3C1 ways. All right. Now, once you have done it, okay, once you have done it, you are left with, you are left with overall three options. Okay, so you had four options, A, B, C, D all together in the problem, out of which you have selected one for two identical, right? And you will be selecting two more, okay, out of these three. So 3C1 into 3C2, okay, so 9 is going to be your answer. Okay, just if you have not got it, okay, if there is a problem in your, if there is a question in your mind, just hold onto it. I'll solve it right away. Okay, so by, by giving you an example, right? So these nine cases could be, and obviously I'm not going to draw all the nine cases, but I'll just give you what I'm talking about. Suppose you have selected B. Okay, suppose you have selected B, you're left with A, C, or D. Okay, so you can go with AC. So BBAC is going to be one scenario. You can go with AD, BBAD is going to be a second scenario, or you can go with BBCD, your third scenario. So three scenarios for BB, three scenarios for CC, and three scenarios for DD. So that's how, we make nine scenarios. Okay, right. Now, let's talk about the third case. A third case could be that there is no, there is no different thing. There are four things which are identical but divided in a pair of 2 2. Okay, sorry, yeah, there are four things which are identical but which are divided in the pair of 2 2. Okay, so I'm talking about two identical and two identical. Okay, how many options do we have for these two identical? Again, we have B, C, D, as your options. All right, and herein we have to select two things that could be either B or C, B or D, or C or D. So 3C2, it's going to be what? 3. Okay, 3C2 is going to be 3, and this is your another, another case. A, a different case could be, so see, if you can see clearly, the way I'm making cases and the way you should also be making cases is try to, reduce this number. Okay, so, from upward to down, it is increasing, and try to increase this number downwards. Okay, that is what you should be doing. All right, now let's talk about another case. Okay, there could be, just one thing different, or and three things identical. Okay, is there a possibility of three things identical? Yes, there is a possibility. We have B and D, okay, to satisfy that particular case. So let me make the fourth case one different and three identical. Okay, so for three identical, I have just two options, B and D. Okay, what I'll do is I'll select one out of these two, so that will be 2C1. Okay, and once I've selected one out of these two, I am left with three options, out of which I can pick just one for different. Okay, so 2C1 into 3C1, which is equal to what? 6. Yeah, 6 is your answer over there, right? This is your fourth case. All right, uh, I hope you are with me, till this point of time. I am not going to bore you, and that is why, I'm trying to be, trying to get back to you altogether. Okay, so these are the four cases which we have encountered at this point of time. Okay, and the fifth case is going to be what? If there is no different but all the four things being identical. Okay, is there a possibility for that? Yes, we have D, 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 D. Okay, so I'll just mention the fifth case over here. We have four identical. There is just one possibility of D, so 1C1, it is equal to 1, and it is your answer. Okay, This is something which was my objective of helping you understand how to draw, how to write the cases. The reason I took this particular problem is because, as you can see, every case is possible over here, right? So for example, in this particular scenario, triple A 5 times B and 2 times C, the first case was not possible, right? There could have been other cases also, which would not have been possible. Let's not go into the details of that. But the reason I took this particular case is to help you understand how exactly you draw cases for this particular thing, and secondly, how exactly do you find the number of selections of these particular things. All right, now all you have to do is add these values to find the total answer, to find your final answer. So 1 plus 1 2 plus 9 11 plus 3 14 and 6 20 is your total number of selections that is possible for this particular thing. Okay, then how many arrangements are possible? Do you directly multiply it by 4 factorial, 3 factorial, 2 factorial? No. For every case, you solve the permutation part as well. Okay. For every case, you solve the permutation part as well. And that is exactly what we are going to do next couple of minutes. All right. Okay. So what we will do over here? In this 4C4 scenario, I mean, in this one scenario, all four are different. So the number of ways, this one combination can be arranged is 1 into 4 factorial, because all are different and you have to deal with all n factorial, remember. So 24 is your answer over here. Similarly, for this 9, we have two elements which are same and two elements which are different. So again, I'll multiply this 9 by 4 factorial, but I'll divide it by 2 factorial as well, right? So it's 9 into 4 factorial by 2 factorial, which is equal to, 24 by 2, 12, 12 into 9, 108 is your answer. Okay. Similarly, if I'm talking about, these three cases, I'm talking about, a scenario like, let's say, AABB. Obviously, AABB is not a possibility over here, but I'm just giving an example. Okay. So for these three cases, 3 into 4 factorial, but I have two repetitions of two things. Okay. So 4 factorial by 2 factorial, 2 factorial, 24 by 4, 6 into 3, 18. Okay. Now, if I talk about this particular thing, 6, again, I'm talking about a case like 3 times A and 1 time B. All right. So it will be what? It will be 6 into 4 factorial by 3 factorial, right? And it is going to be 6 into 4. That is again 24. And finally, for this particular case, this one, the lone warrior, all D sitting alone, right? There is just one possibility of arrangement, D, 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 D. And how that is 1 into 4 factorial by 4 factorial, which is again just 1. So if you add all these circles, 24 plus 108 plus 24 plus 18 and plus 1. So what you're going to do, what you're going to get, 20, 20, 48, 66, 174 and 175. So 175, if my calculation is not wrong, okay, 175 is your answer for this particular thing, right? Now, when I look at it, it looks very hodgepodge, but you can easily understand because you went through it step by step, right? Our priority is, first of all, this drawing the cases. Second is identifying the possibilities of those cases. Okay. Third is about finding the total number of combinations. And fourth is about finding the respective arrangements. Okay. That is how we basically deal, with the case based approach. Okay. And this is something, see, in which I took a lot of time, because that is something which was really very, very needed. Not all students are, and I would say more than 50-60% of students are not really able to draw the cases, and they just leave the problem. Try to understand, if you happen to solve this problem, you're going to get better than almost 80% of the students who have left this problem, right? And the more you solve this kind of a problem, the better you will get, obviously, in terms of speed, in terms of, clarity and each and everything, right? So this is how, and this is what, the 4 quadrants of PNC is all about. The first thing, right? So different, identical, all, and not all. Okay. So this is how, that is how, we solve that particular thing. Okay, now let's move forward, right? Now let's talk about, because see, what so I'll be there to guide you today and tomorrow, but eventually you should also be you should also be able to understand how exactly should you be studying the topics, which topic to study, which topic to leave, and so on. And this particular priority matrix, the aptitude priority matrix, is something which, if you understand, if you abide by it, if you try to arrange your topics according to this, you will actually be able to solve your this problem in very less time, and you will be actually to create your your schedule very properly when it comes to aptitude preparation or any other preparation also. Okay, so try to understand this particular thing, that whatever topics that you have, be it aptitude or be it academics, just try to segregate them on two axes. Okay, so one parameter could be could be the importance of that particular topic. Is it not important, is it very important, or is it moderately important? Okay, and then talk about the difficulty of that particular topic. Is it not at all difficult, very easy? Is it very difficult, I don't want to study it anyway? Or is it a moderately difficult topic? Okay, so just try to just try to arrange, just try to understand what the topic is all about in terms of its importance and in terms of its difficulty. Once that is done, just pick those topics in these nine boxes that we have. Okay, and try to understand when it comes to a smart preparation. Okay, and we are talking about the smart preparation in terms of time efficiency, in terms of resource efficiency, right? Always try to study this particular section first. Okay, followed by this, followed by this. Okay, 1 2 3, the numbers speak for themselves. I really should not write and try to uh, play with this diagram as a whole, but the numbers speak for themselves: first, second, third, fourth, fifth, sixth, and seventh, eighth, and ninth. Okay, this is something according to which you should prioritize your academic curriculum, your aptitude study, your whatsoever that you want, that you're very serious for, be it your be it your competitive examinations, be it your semester examinations, whatsoever. So this is something which will really help you to understand, and it will take what, 15 minutes of your time, right? Maybe 20, maybe half an hour, but that particular half an hour will be so will increase your efficiency in such an effective way that you will complete the topic right well on time. Okay, all the topics. So try to understand this particular thing and try to implement it. Okay, right after this this webinar is this webinar is over. All right. Okay. All right. Now let us talk about the 8 boxes of distribution. Okay, what I'll do, what I have actually done over here, there are in PNC, and this is the last topic of PNC, after which we will shift to the multiplier thing. Okay, so the 8 boxes of distribution helps you understand, okay, when to use which type of, which formula or which concept when it talks, when we're talking about distribution of things in groups or places. Okay, so again, based on according to the 4 quadrant trick that we that we understood previously. All right, let us talk about again things which could be different or identical, and then there could be groups in which you're not allowed to to have blanks, or you are allowed to have blanks. Okay, so one is with blanks, one is without blanks. What is about these three, these 3 boxes? Why I have not written the formula for these 3 boxes? Because that is not important when it comes to campus placement preparation. Okay, right? And even in even in competitive exams there are different approaches, so you not really mug up these 3 formulas as whole. Okay, so, and this is something which I believe all of you or a lot of you would already be aware with. Okay, so what do we understand when we say different groups with blanks? Okay, so similarly I say that in how many ways can can you arrange 5 different people in what 4 different cars? Okay, in how many ways can you arrange 5 different people? Okay, 5 different people in 4 different cars. Okay, and when we talk about things, people, we are talking about n, and when we talk about cars, groups, in which we have to arrange, we are talking about r. Okay, so what the first person will say? Okay, the first person will say, hey, I have 4 options. I can go with car A or B or C or D, right? So the first person will have 4 options. Similarly, The second person will say the same statement. Again, I have four options. I can go in A and sit along with my friend if this person has already picked A, or I can go alone maybe till this point of time. So all these people will have the same response. Try for, because they did not really care about that a car may be left empty, or maybe a couple of cars or three cars may be left empty. Okay, they don't have to care about that particular thing. When you come across a problem in which you don't have to, you don't have to take care of the blank constraint, always go with this particular thing, r to the power n. Okay, similarly, when we have different identical things, okay, when we have identical things, but we are talking about different groups, allowed or not allowed, the formula is pretty much simple for both of them. One is n plus r minus 1 cr minus 1, and the other is n minus 1 cr minus 1. The reason of of drawing this 8-box approach is to help you visualize and understand when to use which particular trick. Okay, now, so this is something which you already know, but I'm just trying to help you visualize how to remember that particular thing. What about principle of inclusion and exclusion? Okay, I do have to cover other concepts as well, but yeah, let's take one problem. Okay, and with the help of that, let's try to understand what this principle of inclusion and exclusion is all about, right? And this is a very, very important problem. Again, this is a very, very important principle altogether. And this is something which you will anyway, come to understand, come to study. And, a lot of problems might, or at least one problem might be asked definitely, from this particular concept. So let's see this particular question. What is the number of ways in which 5 people can be distributed amongst 3 buses such that no bus is empty? Okay. First of all, understand, do we have to use principle of inclusion exclusion? Okay. 5 people, obviously people are different unless we have been given twins, okay, or things like that. So people are different, right? Amongst 3 buses. So the buses, unless mentioned otherwise, are different, right? Such that no bus is empty. So we are talking about, we are talking about different things, different groups, okay, but without any blank spaces allowed. So we are talking about principle of inclusion exclusion. Okay, this is what we are talking about. So always, remember the approach, how we have to actually solve it. Remember this particular thing, r to the power n, and this is something which will create the base for this particular thing, right? Okay, so my n over here is 5, that is 5 people, and my r over here is 3 buses. Okay, without blanks, with blanks, the answer would have been 3 to the power 5. Okay, now what you have to do is, you have to play with the combination of this particular number, that is r, and you have to subsequently decrease the numbers, okay, in terms of powers. So, just see. So minus 3c1. Okay, so you will exclude, a few cases, 3c1, and this number 3 will now reduce to 2. So 2 to the power 5. Okay, plus. So why it is called principle of inclusion and exclusion? Because we are trying to exclude something, and then we are also trying to include something. Okay, so try to just go in this direction until till the point you come across 1 to the power something, whatever that something is. Okay, so minus 3c1, okay, 2 to the power 5, plus 3c2, 1 to the power 5, and this is your answer of principle, by applying the principle of inclusion and exclusion. Okay, similarly, just for your reference, okay, if you were given, let's say, 6 people and 4 buses, how you would have solved it? You would have solved it 4 to the power 6 minus 4c1, reduce this number, 3 to the power 6, plus 4c2, reduce once more, 2 to the power 6 minus 4c3, 1 to the power 6. We have achieved the number 1. The story is over. This would have been your answer if there were 6 people and 4 different buses. Obviously, all same, all different. Okay, I'm sorry, I mean all different. Okay, all different people and all different groups also, buses, cars, envelopes, whatsoever. Okay, so this is how the principle of inclusion exclusion performs, okay, or functions. So exclude, include, exclude, include, exclude, include. Point number one. Point number two, just increase, keep on increasing the C part. Okay, 3C1, 3C2, 3C3, 4C1, 4C2, 4C3, and keep on decreasing the power part. Okay, 4 to the power 6, 3 to the power 6, 2 to the power 6, 1 to the power 6, and so on. All right. So this is something which you do, in terms of this particular thing. And what if these groups, these buses are also identical? In that particular case, you divide this particular number by uh, r factorial, that is 3 factorial. So now I'll solve for this particular problem. 3 to the power 5 is 243, minus 3c1 is 3, 2 to the power 5 is 32, 32 into 3 96, plus 3c2 is 3, and 3 into 1 to the power anything is going to be 3, right? So 243 plus 3, 246, minus 96 is equal to 150. So 150 is your answer to this particular problem. Okay. And if the three buses were all, same, I mean identical, you would have divided this answer by 6, that is 3 factorial, and 25 would have been your new answer. All right. This is how you solve the problems of inclusion exclusion. Okay, principle of inclusion exclusion is how, this is how it performs. All right. This is what the next problem was all about. So there were 5 different fruits, 3 identical. We have solved this problem right here only. Okay, so let's go forward, and now I'll try to pick up a little bit of speed, because we are already 1 hour past this particular thing, right? And till this point of time, what we can say that we have actually understood few things. First of all, how to understand which basic formula to use when it comes to permutation and combination. That is something which we have visualized. Point number one. Okay, we have also solved problems related to constraints in order to understand how exactly should we be dealing with constraints. Okay. Point number two, we have come across this 8-box approach. Basically, there are 5 formulas, so you can call it 5 by 8 approach. Okay, whatsoever. It's totally your choice, right? We have come across that particular thing in order to understand when it comes to distribution of things. Okay, how exactly do these formulas perform, when to use what. Okay, so that is something which we have understood till now. Now let's talk about a very, very, very basic concept, that is the concept of multiplier. And why we are talking about it, because I think the next slide, yeah, it will speak for itself. You would have come across these formulas. Profit percent is equal to something, loss percent is equal to something, selling price is equal to something, something, something. And there are formulas for profit, loss, and discount. There are formulas for simple interest, compound interest, and finally someone came up with this trick of 2 successive percentages, right? A plus B plus AB by 100. Wow, right? So what we will do, and these formulas are something which obviously the foundation in each and every trick is on these formulas. So if anyone who tells you that it is not important, obviously these are important, right? But these are not necessary to be remembered, right? And the game of multipliers, that is these the thing that we are going to study right now, upcoming, is what will help you understand that how exactly can you solve the same problems that could have been solved using this formula, but without any formula approach. Okay, but maybe with just 1 or 2 lines, by visualizing the problem. Okay, see, every aptitude problem is a real life problem. If the price of the petrol is increasing, that is a real life problem, right? Not just in aptitude, but in real life as well. Okay, and this is what we are going to solve over here, not by using the formula, not by using any calculator, but by using the concept of multiplier. Okay, all right, so here we have something, what process or a flow over here. Okay, and this is by which we would be trying to understand how the game of multiplier looks like. Okay. Okay, so for example, you have a base number 100. Okay, you have a base number 100, and just give me 2 seconds, let me have 5 seconds, let me have water. And meanwhile, if you have any doubts, please keep posting. I'll try to take all the doubts at the end of this particular session, right? Okay. All right. All right. Okay. So 100 is your base number. Okay. If you increase by 20%, plus 20% is basically increasing the number by 20%, you will get 120. Okay. If you decrease the same number, so let's go with the, the top word first. If you again increase it by 10%, so 10% of 120 is what? 12. 120 plus 12 is 132. Okay. If let's say if I again want to increase this number by 10%, if I again want to increase this number by 10%, what will be the value? 132. 10% of 132, 13.2. So 145.2. So is your answer. Is that okay? 132 plus 13.2, 145.2. Okay. Right. Now the formula A plus B plus AB by 100 is limited to just two processes, right? What if there are three? Just like this particular case. Okay. That is, that is when the multiplier comes into the picture. Okay. So when we're talking about increments, okay, 20%, just write 1 and 20 followed by it. So if you multiply 100 by 1.20, you will get this number, 120. If you multiply 120 by 1.10, that is 1.1, you will get this number, 132. And if you multiply 132 by, again, what is the multiplier of 10% increment? 1.10, you will get this particular number. Okay. And if you want to directly go from here to here, all you need to do is multiply just two numbers, 1.2 into 1.1. Okay, so 1.2 for this 20% increment, 1.1 is for this 10% increment. You don't, you don't really need to apply A plus B plus AB by 100. Similarly, if you want to go from here to here directly, you don't need to, solve first of all for A plus B plus AB by 100 and then again solve for the new A plus this B plus AB by 100. What you can actually do is 1.2 into 1.1 into 1.1. Problem solved. Okay, just multiply these numbers and obviously common sense, multiply these with 100. Okay, multiply this by 100 in order to get your final answer, right? So, and this is pretty much very, very time effective, right? Similarly, when it comes to, the decrement, 10% reduction would make the multiplier 0.9. Okay. Similarly, if we have, let's say 20% reduction, the multiplier would be 0.80. If we have six, if we have 16% reduction, okay, the multiplier would be 0.84. So 100 minus whatsoever that is and 0 point whatsoever that is. Okay, whatsoever the result is. So 100 minus 10%. 10% of 100 is 90 and 90 plus 10% of 90, that makes 99. Again, this is something, nothing but 100 into 0.9 is 90, the multiplier approach, and 90 into 1.1 is 99. And if you want to go, let's say from here to here directly, what it is, 1.1 for this particular thing multiplied by 0.9 for this particular thing. 11 into 9, 99. Two decimal places, 0.99. 0.99 into 100, 99. Okay, the very same number. So this is very easy. And obviously, few of you might be wondering why the hell I'm talking about this so easy concept. And the reason we are discussing this very simple, maybe a time waste approach is because this will help us not waste a lot of time in problems, right? And yeah, so this is all about multipliers. Before we jump into the problems and how exactly do we apply this particular game of multipliers when it comes to solving problems, let us understand this basic concept, which is again very, very important, by the way: product stability ratios or pairs. Okay, so let us say that there is a number 20%, or let me solve it like this. Okay, let me solve it like this, right? uh, let's say I have a number 100. Okay, if I increase it by 25%, my number would be 125. Okay, by how much percent should I decrease 125 in order to come back to 100? The answer is not 25, obviously, right? So in the basic terms, the reduction is of 25. Okay. And from which quantity are you reducing now? From 125. So it's 1 by 5, or basically 20% reduction. Okay. Similarly, let's say, I have another number 100. If I increase it by 50%, if I increase it by 50%, my answer will be 150. But in order to decrease this 150 to come back to 100, I do not have to decrease my number by 50%, right? I have to decrease my number by just 33.33%, right? And this is something which 25 increment, 20 decrement, 50 increment, 33.33 decrement. This is something which we call pairs. Okay, the product pairs, stability pairs, whatsoever name you want to give it. The name is not important, but the concept is, right? So, and why the concept is important, we will see, right? Because eventually this combination will help us solve the problem along with the concept of multiplier without applying the formulas or remembering too many of them. Okay. Okay. So, and let us solve one for ourselves. Okay. So how do we exactly solve it? So, and how do we exactly find, so 25% is what? 1 by 4. 1 by 4. Okay. Now, let's say if we have to talk about, if this is about increment. Okay. If we have to talk about the decrement pair of it. Okay. The decrement pair of it, just add 1 to the denominator. So it will be 1 by 5, which is equal to 20%. So 20% is the decrement pair. So if 25% increases, 20% decreases. Okay. But if 25% decreases, okay, if there is a reduction by 25%, will there be an increment by 20%? No. Okay. So for increment, just subtract by 1. So 1 by 3, which is equal to 33.33%. Okay. 33.33% is your answer. Okay. So this is how you solve, you find the pairs. Okay. Similarly, let's say, we have to find, both increment and decrement pairs of 1 by 3 or 33.33%. So if we increase a quantity by, 1 by 3 or 33.33%, the same would be, in order to get back to the same quantity, we will have to decrease the quantity by 25%. And if we reduce a quantity by 33.33%, we will have to increase the same quantity by 1 by 2, that is equal to 50%, in order to come back to that particular thing. Okay, right? And for example, there is a quantity 30. If we decrease it by, 1 by 3, 33.33%, the quantity will become 20. And in order to go back from 20 to 30, you have to multiply, or you have to, increase this 20 number by 50%. That is into 1.5. So 20 into 1.5 is 30, right? So that is how we actually solve, or that is, what this product stability ratio is all about. So enough of things that we have discussed by, with this game of multiplier and the product stability ratio. Now let's directly jump into the questions, okay, that we have created for you. Okay, so let us read this particular problem. Yeah. So okay, try to solve this problem if you want to, but yeah, let us just try to visualize this problem as such. After getting a 20% discount on the marked price, okay, so marked price is something, the sticker price. Okay, the shopkeeper is able to make a 20% profit on the transaction. Okay, cool. By how much percent did he raise the price of the item? So the shopkeeper seems to be very clever. Okay, he is giving a 20% discount, okay, on the marked price, okay, just to attract the customers. Good marketing. And still, after doing that, he is able to make a profit of 20% on the overall transaction. What we have to understand is by how much percent did he raise the price of that particular item. Okay, this is what we have to understand, right? If there is an answer which you have come up with, you can write it in the chat box. Okay, yeah, so that is true, 50%. Okay, and let us try to visualize this problem in terms of real life experiences. Okay. So what will happen? Eventually, so let me draw the entire diagram first of all. Okay. So this is where the shopkeeper is. Let's say, the cost price of, what the shopkeeper is. What shopkeeper would eventually do? He would want to go from here to here and, increase the price. He would want to go from point number A, position number A to position number C, increase the price. Okay. And then he would go back and offer a discount. So increase the price is what? Increment. Okay. He would offer a discount. Okay. In order to come back, in order to ensure that still he is making some profit percentage. All right. This is what the journey of the shopping would look like, for the shopkeeper. He would increase the price first of all to reach to the marked price. Then he would offer a discount, and eventually because of that, he would be, gaining some profit. Okay. So we have, going from here to here, we have a profit of 20%. Okay. And going from here to here, we have a discount of 20%. Okay. We have a discount of 20%. Okay. Our basic objective, think like a shopkeeper. Your basic objective was to go from A to C. Okay. Altogether. Okay. Via B. How can you do that? If I try to reverse, okay, because I already have something that goes from A to B. If I also have something that goes from B to C, I'll be very happy, right? But I have something that goes from C to B. And that is where product stability ratios come into picture. Okay, 20% reduction, 1 by 5. We need to go upward, 1 by 4. That is 25%. Okay, so 25% is what the journey from B to C would look like. Okay. And finally, the entire journey from A to C in terms of A to B and, B to C would be 20% increment and 25% increment. The multiplier would be very simple, 1.2 into 1.25, 1.50, which basically means 50% increment. Okay. That is how we try to even assume the value to be 100. Okay. Things like that. Okay. And we just visualize the problem in terms of real life thing, and we understand the journey altogether, and we just move the forward journey. Okay. And trust me, and just giving you a tip on that, this is something how we would be solving the Bayes theorem as well. Okay. We will not really be mugging up the formula of, what Bayes theorem is. We would be just understanding the journey of the problem, and we would be taking it in the very same direction, right? This is how you eventually solve problems like this, right? Similarly, this problem is again, with the very same concept. A shopkeeper wants to earn a minimum profit of 20%. At the same time, the discount which he wants to offer is 25%. What should be the, minimum percentage markup over CP? So again, it's the same problem, but now with different data, right? Our basic goal is to jump from here to here, but eventually we have to make 20% profit. And in the reverse direction, we are giving a 20% profit. And in the reverse direction, we are giving a 25% discount. If we try to move forward in this direction, 1 by 4, 4 minus 1, okay, 1 by 3, that is going to be 33.33% increment. The final answer in terms of multiplier is going to be what? 1.2 into 1.33. Okay, maybe you can multiply 13 into 12. Sorry, 133 into 12, 266, 133, 6951, 1.596. Okay. And 0.333333, will obviously make it to not 59.6%, but almost 60%. All right. And this is how we have again solved this problem by just using the concept of multiplier and understanding what product stability ratios told us. Okay. And see, we did not take the base value 100. Again, that is still a very good approach to take. You can say, okay, what if my base value is 100? Okay. And this is how, I offer 25% discount, 20% profit, and so on, right? So you can go with that particular method as well. But why do you want to go with a method which will take you, to assume something when you can clearly understand the journey? Because in real life, you do shopping, right? In real life, you do shopping, you do understand what a shopkeeper is, who a shopkeeper is, what his or her intentions are in terms of profit, loss, or discount, right? So if we truly understand the journey, why not just use the same method, in order to solve the problem, right? And this is how we can solve this particular problem as well, and again, the petrol prices, the topic, the hot topic of the day, of the entire month, let's say, if the price of petrol is increased by 30%, by how much percent must you reduce your consumption so that your expenditure is increased by only 10%? Okay. So let's say, the price of the petrol is increased by 30%. So you say to yourself, okay, I need to cut on my, consumption. But eventually you understand that, okay, if at this point of time I used to spend rupees 100, maybe I can go with 110, 10% increment. Okay. But and how do we exactly solve this problem? Again, without using the base value 100, 110, 130, and so on. So how will, how the process of this particular thing would look like? Suppose, you are here right now. Okay. You understand, that the price of petrol is hiked by 30%, right? So what is the first thing you will do? You will reduce your consumption. Okay. You will reduce your consumption. Okay. That, okay, man, right now I was using 5 liters. Let's go with 4 liters. Okay. Let's take public transport, things like that. Okay. Once you have reduced your consumption, still your cost is going, is increased by 10%. Okay, your cost is increased by 10%. And by doing all of this, why exactly, is all of this happening? Because the price of the petrol is increased by 30%, right? This entire thing is happening because the price of the petrol is increased by 30%. If I call this X, okay, similar, if I call this X into 1.1 for 10% is equal to 1.3 for 30%. Okay. So what I have done, it is going to be 30 and 10 over here. Okay. So what is going to be there? You reduce your consumption. Okay. And by the way, apologies for the error over here, but yeah, you reduce your consumption and then you pay for the hiked price. Okay. You pay for the hiked price. You pay 1.3 times of, what what you were actually paying. You pay 1.3 times of it. Okay. And by doing all of this, you are increasing your, your total expenditure by 10%. So it's not going to be X into 1.1 is equal to 1.3. It is going to be X into 1.3 is equal to 1.1. Okay. Your X is going to be what? 1.1 by 1.3. And if you try to solve it, you will get eventually around 0.85. Okay. What do we mean when we say 0.85? That basically means my reduction in consumption is 15%. Okay. If it was 0.9, 10%. If it was 0.65, 35%, and so on. Okay. This is how we actually solve the problem by using the concept of multiplier and the product stability ratio. Okay. Again, because there was an error that happened over here, let me just walk you through the journey once again. First of all, you will reduce the consumption. You will say that, okay, now from now onwards, I'll use 10% lesser of the petrol, or on every second day, I won't use my bike or car. I'll use metro or public transport, right? And, with whatever consumption that you reduce, you will eventually go to the petrol pump and pay 30% higher. Okay. Once you have done these two steps, you will look at your wallet and you will say that, okay, I have still paid 10% more than my previous consumption. Okay. So the combination of these two steps is a result of 10% increment in your expenditure. Okay. And that is how, you actually solve this particular problem as a whole. Okay. Right. So, and this is something which I'll probably leave to you, given the time that we have left, because we actually have to, talk about the time, speed, distance, and time and work problems also over here, right? So this is something which we will maybe, solve later, or you can come up with the answer right away. Okay. At the later point of session or tomorrow, no issues, right? Now, when it comes to because in terms of multiplier and, with all of this, squaring or multiplying numbers, eventually squaring will, help you a lot, in order to understand and in order to solve the problems in a better time. Okay. So, and in a lot of problems, what you will see is increment from 1% to 25%. Okay, there are very less problems in which you will see 30-40% increment. Okay, similarly there are very less problems in which you will see 30-40% increment. Okay, so eventually my multiplier is going to be from 0.75 to 1.25, right? And that is why we are talking about the square trick of how exactly can you multiply the numbers from 75 to 125. Okay, so let's pick any number lesser than 100, and let's pick then another number greater than 100. Okay, let me go with, let's say, 89. Okay, so draw it on the first circle. So how far is 89 from 100? 11. So write the square of 11 on the right hand side, 121. Okay, subtract 11 from 89 to write the resultant on the left circle, 78. Okay, now just talk about these two last numbers, 21, and carry this, whatever that remains over here. So 78 plus 1, 79. So 7921 is the square of 89. Okay, that is your square of 89, and that is how we actually find the squares of these numbers without any long approach, until and unless what you should be. Okay, I'll yeah, Saundarya, sorry, I'll repeat. Okay, so, and I'll repeat with another example, so that it benefits you and it benefits other students as well. So let's say you have to multiply, let's say 77. Okay, you have to multiply 77, sorry, squared 77. Okay, how far is 77 from 100? 23. So write the square of 23 here, 529. Now you should be, and I believe all of you, remember formulas till 25. Okay. So write the square of 20, square up to 25. So write the square of 23 over here. Okay. And subtract 23 once again from this particular number. Okay. So this is going to be what? 54, right? So 54 is going to come here. If you subtract 23 from 77, just write the last two numbers over here, 29, and carry whatever that remains over here. So 54 plus 5, that is 5929. Okay, that is your answer of 77 square. Similarly, if I have to talk about, let's say, the square of 116, how far is 116 from 116? So let me write the square of 16, 256. Okay, let me now, so when it comes to lesser than 100, reduce, more than 100, add. Okay, so 116 plus 16, 132. Again, very simple, 56 over here, and 132 plus 2, 1 3 4 5 6 is your answer of the square of 116. Okay, that is how you eventually find the squares of these numbers. And how exactly does it affect? Because let's say if there is if there is a successive decrement of 11%, right? So that is how the multiplier becomes 0.89. You can easily say that the final value would be 0.7921 times of whatever the value is. Okay, or my reduction is almost 20.8%, like that, 20.79 precisely. Okay, so this is why remembering or this particular trick can be important, okay, in terms of saving your time of okay, Muskan, so the time for tomorrow's webinar is again obviously the same time, 7 to 8:30. But I don't think I'm going to leave you people at 8:30. It is going to take a lot of time tomorrow as well. But yeah, let's we will wind up from 7 to 9 maximum. Okay, so let's get back to what we were discussing. So this is how you eventually solve the squares of this particular thing. All right. Okay. Now let's go forward to the last trick that we have in our bucket, that is the LCM and ratio trick. All right. And this LCM and ratio trick will help you solve two types of problems. One is time, speed, distance, and the other is going to be time and work. Okay. So let's take this forward. Eventually, if you have already studied time and work, okay, one time you would have come across the concept or the formula of 2xy by x plus y, right? Even in the time, speed, distance. Okay, this formula is applicable when it comes to average speed. Now you tell me, or you ask yourself, that if there are three people who are going to do work if there are three journeys in time, speed, and distance, and not just two, do you want to remember formula for three? If there are four, like, in this case, there are four, and similarly, in the next case also, there are going to be four, cases in the next problem. Do you actually want to remember formula for three, four, five, and so on? Because not every problem is going to have just two people, right? How do we solve these particular problems? It's very simple. All you need to do is you should be able to calculate the LCM, which you already know since class what, fourth, fifth, sixth maximum. Okay, maybe sixth. Okay, so I don't really remember, but I'm just guessing, right? So you know how to solve the LCM, and that is something which will help you excel, and solve a lot of time when it comes to three, four, or five people. So in terms of two, obviously, go with this formula 2xy by x plus y. But when it comes to, four, five, six is obviously not the case. It's not going to be ever, but maximum they can give you is three, four, or in very rare scenarios, five. All right. So here we do have a problem with four individuals, A, B, C, and D. Okay. They can do a piece of work in 6, 8, 12, and 9 days. Okay. And what we have to calculate is in how many days would they be able to finish the work together. Don't do this particular thing, that 1 by 6 plus 1 by 8 plus so on. That is not how we would be solving, or we would be encouraging you to solve this particular problem. Okay. Just see, look at the numbers in terms of days, in terms of time. We have 6, we have 8, we have 12, and we have 9. Just take their LCM, nothing else. Okay. And you should be fast at taking their LCM. If you are not, you can even take their products. Okay. So 6 into 8 into 12 into 9. That is also what something, what you can do. Okay. So if you take their LCM, okay, I believe it is going to be 72. Okay. It is going to be 72. Now assume that this is your total work. Okay. Assume that this is your total work. All right. So 72 for A, when you divide by 6, you can say that the efficiency of A is 12. Okay. 72 by 6. For B, 72 by 8, that is equal to 9. For C, 72 by 12, that is equal to 6. And for D, 72 by 9, which is equal to 8. In the second circle, or in the second layer of circles, what we have got is the efficiency of these people by assuming that this is your total work. Okay. Efficiency of these people in 1 day. Okay. What you need to do is just add these four numbers, because because in general it is easier to add natural numbers than adding these fractions. All right. So 12 plus 9, 21, plus 6, 27, plus 8, 35. This is your total work entirely, and this is your total work done by all four of them in 1 day. How many days would they take? Basic arithmetic, basic division. 72 by 35. So 2.5 something, almost 2.6. Okay. 2.06, sorry, not even close to 2.6, 2.06, between 2.05 and 0.6. Okay. So that is what the answer is going to give. That is what the answer is. 72 by 35 days is your answer. Okay. What we have avoided taking X as the total work, and then, X by whatsoever that approach is. What we have avoided is, 1 by 6 plus 1 by 8 plus 1 by 9 plus 1 by 12. We have actually done the very same thing, by the way, but we have done it in terms of visualizing the problem. Okay. We have not taken multiple additions of fractions, which would have taken a lot of time. We have reversed the approach altogether. Okay. And this is something which will help you, okay, in order to solve the problems of time work, right? Now let's move to another scenario in which we will use the same concept in order to solve the problems of time, speed, and distance. Okay. So let us look at this problem. A car travels, and meanwhile I speak this problem, I read this problem, I'll try to draw the diagram as well, the journey diagram. Okay. So a car travels the first half. Okay. So let's say this is, your entire journey. The first half, that is 1 by 2. Okay. That is 1 by 2 at a speed of 40 km per hour. Of what remains? So if 1 by 2 is covered, 1 by 2 remains. The half is covered at 50 kilometer per hour. So 1 by 4 is covered at 50 kilometer per hour. Half of the remaining. So again, 1 by 4 is now still left. Okay. Half of the remaining, that is 1 by 8, is covered at 60 kilometer per hour. Okay. And the remaining, that is obviously 1 by 8 now, okay, fortunately is covered at 30 kilometer per hour. You need to find out what is the average speed of the car. Obviously, the formula is 2xy upon x plus y, or 3xyz upon xy plus yz plus zx. I don't know. Okay, whatever that formula would look like. Do you really want to remember, or just mug up those formulas? No. Just try to learn how to draw trees, these circles. Okay, and eventually every problem is a cakewalk in that particular thing. Okay, so what are the numbers that you can see on the screen? 40, 50, 60, 30. Just try to take their LCM. Okay. Their LCM is going to be what? 600. Okay. It could be lesser also, but 600 is the number, that is coming to my mind right now. Okay. So 600 is easily, perfectly divisible by all of these numbers. But there are other numbers as well. 1 by 2, 1 by 4, 1 by 8, and 1 by 8. If you are someone who is scared of decimals, fractions, there is something that that I can help you with in this particular thing. Don't go with 600, as assuming that is your total distance. Just multiply this number with the biggest of all of these numbers, okay, in the denominator. Okay, so that is 8. Just multiply 600 by 8, that is 4800, and assume that this is your total distance. Okay, assume that this is your total distance. If you cover half of this total distance, okay, that is 2400 at a speed of 40 kilometer per hour. Okay, 2400 by 40, what you will get? 60 hours of time. If you cover 1 by 4, that is 1200, 1 by 4 of 4800, that is 1200 at a speed of 50 kilometer per hour, your time taken would be 24 hours. If you cover 1 by 8, so that is going to be what? 600. 600 at a speed of 60 kilometer per hour, your time is going to be 10 hours. And if you cover another 600 at a speed of 30 kilometer per hour, your time is going to be 20 hours. This is your total distance. And the addition of these four is going to be your total time: 60, 24, 84, 10, 94, and 114. So 4800 by 114, or if you want to, just reduce it, that is going to be 2400 by 57 kilometer per hour is your average speed of the car. If you try to solve it, it's going to be 2280, 2280, so 40 and 120. So it's going to be roughly around 42 point something, okay, in terms of decimal, right? Yeah. Okay. But eventually we are not going with a conventional method. We're also not going with the short tricks, because you and I at this point of time, we both agree that the short tricks mentioned in those blogs, those beautiful books, were limited to just 2 scenarios, or probably someone would have mentioned for 3. Okay. What we are trying to do over here is understand that it's not the game of tricks, but the game of visualizing a problem, right? And that is something which we have done here, and that is something which we did here also, okay, in terms of LCM tree trick of time, speed, and distance. Perfect. Now, without wasting much time, let us go to the last problem and the last trick, and after which we have few free products for you. We have as we promised, so whoever would be a part of this bootcamp would be given free products. So we have a couple of products for you, and we are going to have more tomorrow as well. But before that, let's let's solve this particular problem of contractor, contract work, time and work. So this is something, a very standard problem. A lot of competitive examinations have this sort of modified version of this. Your campus placement aptitude test are definitely going to conduct one or more problem of this particular scenario in higher chances, but high probability that this type of problem would be there in maybe a couple of tests, right? And how do we exactly solve this? So generally what people do, Okay, and what I'll do, considering the time limitation that we have, I'll directly jump into the trick, okay, without going with the conventional methods. And that is something which I have not done for previous problems as well, right? But I have told you what those conventional methods look like. So how people generally solve this problem is, the basic method is, let us assume X. Okay, the most favorite words of mathematics. Okay, let us assume X, right? Don't go with that. Don't buy that particular method. Okay. Second thing, a lot of people, what they do is they try to multiply, they go with the multiplication method. Okay, so what they do, 100 days, 50 men, 50 into 100, 5,000 is my total work. Now I will solve according to that particular thing, which is again a very good math. Okay, there is no denying that it is it is a bad method just because I have another one in the pocket. So that is still a very good method. But what if I can save your time of multiple multiplications, divisions, and so on with just 2 lines? Okay, what if I can do it? So let's try to do that particular thing over here, right? Okay. So here we have. But before that, let us read this problem first of all. Okay. A contractor estimates that he will finish the road construction project in 100 days by employing 50 men. Okay, so perfect. Every day, 1% of the work is supposed to be completed, right? So after 100 days, 100% of the work is done. However, at the end of the 50th day, he finds that only 40% of the work has been completed. Technically, after the completion of 50 days, 50% of the work would have been done, right? Because we're talking about 100 days. Okay. But maybe the workers are not really working that much effective. The work might be that much difficult. Whatsoever, the reason is we have the data in front of us that 40% of the work has been completed, not 50%. Okay. Now the contractor would be, in a little bit of tension that, now my project will take more than 100 days because my people are not working at the pace what I was expecting. Point number one. Point number two, if the contractor has to eventually just complete the task on time, he might have to employ other people, okay, into this project. That, okay, let me hire 20 people more, but I want this project to be done on time no matter what. Okay. And in this particular case, we are going to solve both these scenarios. Okay. So how many more days will be required to complete the work? Okay, in order to solve this problem, just try to understand this particular thing. Okay, how much work was supposed to be completed at this point of time? 50%. Okay, just ask yourself, how much work was supposed to be completed at this point of time? 50%, 50th day. Okay, and the total work was of 100 days, so 50%. But how much work has actually been done? 40%. Okay, that is your, I'm talking about work done. Okay, work done, right? Expected was 50%, actual is 40%. If I just talk about these numbers in terms of ratios, it is going to be 5/4. Okay, and I'm talking about the work. Okay, and eventually it is a common sense thing that if the work is if the work is let's say lesser, the time will be lesser as well, like, right? So they both go hand in hand, right? Or if my speed is lower, let's say my speed of efficiency is lower, my time will my time will increase, right? And if I'm improving the time, if I'm increasing the time, my efficiency is eventually decreasing, right? So efficiency and this particular time are in the opposite segment, opposite nature, right? So if work is in the is in the ratio of 5:4, obviously that time would be in the ratio of 4:5. That is what you can say, because work and time are inversely proportional. Efficiency and time, particularly. So, you can, if you're getting confused, you can talk about efficiency. So 50% was the efficiency or the work expected, or 40% is what that has been achieved. So reciprocal of 5/4 is 4/5, and this is nothing else but old, actual number of people or initial number of people divided by total number of people, right? 100 by x. Okay, so that gives you 500 is equal to 4x, x is equal to 125. So in general, uh, no, so we are talking about 100 days, not 100 people, 100 days initially and x days finally. Okay, So we're talking about 125 days in total. Okay. And this is how you do not multiply anything. You just see these two numbers, what was supposed to be completed 50%, what has actually been completed 40%. The ratio of this is 5 by 4. So the ratio of time should be 4 by 5. And this time is nothing else but initial time upon final time. Okay. 100 by X. So my final time is 125 days. And that basically means that how many more days will be required? 125 minus 100, which is equal to 25 days is your answer. Okay. No unnecessary multiplication. Okay. In this particular thing, just two ratios and the answer is solved. Okay. Now, if you have to answer how many more men should he employ in order to complete the work on time? Okay. Now, let us look at work to be done. Okay, work to be done. So here we talk about work done. Now let's talk about work to be done. How much work after 50 days? If you look at the project, after 50 days, you should say that, okay, my basic assumption is 50% of the work should have been done and 50% of the work should be done from this point of time. So your expected work to be done is 50%, but eventually because the workers were slow, now your work to be done is 60%. Okay. The ratio over here is 5 by 6. Okay, the ratio over here is 5 by 6. Just do one simple step. Divide this 5 by 6 by this particular ratio. Work done. 5 by 4. 5 will cancel each other out because it is division, not multiplication, right? 4 will go upward. 4 by 6, it is equal to 2 by 3. And this is equal to your old men upon new men power. Okay, so that is going to be what? 2 by 3 is equal to 50 by X. 2X is going to be 150. X is going to be 75. That basically means how many more men should I employ? 75 minus 50, again, just 25 more men I should employ, right? See, this is how we have avoided things like 50 into 100 is equal to 5,000, 40% of 5,000, 2,000, 2,000 by 50, 40. So 40 is, what my workers are doing on a daily basis. 40 by 50 is 0.8 is their efficiency, and so on, so on, so on, so on. No, and eventually I will repeat it again. That is again a good method, right? But this is better. Okay. So this is how we actually solve, or we actually apply the trick of ratio, when it comes to solving this particular problem of contract based. You just need to talk about two ratios, work done and work to be done. Okay. Work done 5 by 4, reciprocal of that is 4 by 5, which is equal to initial days upon total days. Okay. Or new total days. Okay. Now work to be done, just divide this work to be done ratio 5 by 6 divided by work done ratio. Whatever you get, 2 by 3 is equal to old manpower upon new manpower. Okay, not the added one, new. And the difference is what will give you the, the added answer or the reduced answer. Okay, so for example, if 60% of the work would have been completed over here, not 40 but 60, then obviously we would take lesser time. Okay, or we might want to fire few employees. Okay, that eventually my workers are performing very well, so let me save on some cost. Okay, let me just fire maybe a couple of employees in order to save my cost, and still I'll be on time. Okay, so that is how we use this particular trick in order to solve this method. I have taken around 15 minutes extra. I'll just take 5 minutes more before we before we jump into the Q&A. If you have any till this point of time, let us talk about what this prep to placement has to offer. Okay, prep to placement is basically a 2 months internship based live learning and training program for college students. Okay, what do we mean when we say internship based? When we say internship based, what we are saying is the students will get 2 months of internship opportunity to work with MBAtrek. Okay, in multiple domains, in HR, in project management, in UX and product management, okay, and in marketing and business development. Okay, and a proper internship with the proper projects. Okay, why do we say it's live learning and training program? Because eventually we understand that there are generally 3 scenarios when it comes to online learning. There are group classes, live classes, just like what we have over here. There are self-paced courses, okay, which eventually leave to you, okay, that whenever you want to study, you can study. And then there are one-to-one mentoring programs, okay. What this is about, it takes the advantages of all these three things, okay. So we have live group sessions, we have personalized one-to-one sessions, and we have your self-paced courses, but milestone trackable courses as well, okay. So that is something what this prep to placement is. What is the objective? The objective is to help you get the right job through our own job revolutionary job platform, higheq.in. Okay. And that is what, this program is going to offer you. A 2 months internship is in any of these four domains. That is a right fitment for you. So if you want to pursue a career in, let's say, HR, you will get a 2 months internship opportunity in HR. Okay. 100+ hours of training through, as you can see, multiple live groups, personalized one-to-one training, self-paced learning, and internship project learning. Okay. So that is how, we take care of your personalized growth as well as, group growth, your skill development, and so on. Okay. We have, we have our own platform, as I told you, higheq.in. That is, upcoming. It will be launched soon, and we are going to refer you and support you in terms of job hunt by providing you with, first of all, list of companies which hire professionals like you. Okay. And by referring you or helping you is the interviews of the companies which have shortlisted you. Okay. So that is going to be 100% pure job assistant and support program. And finally, we do understand that nothing beats, and trust us, nothing beats one-to-one mentoring. And that is why we have a dedicated career mentor for you in this entire program. We understand that self-paced courses are important, and that is why we have your daily goals. So still, even if you have a self-paced course, you do know what you have to do today, what you have to do tomorrow. You have your daily goals which you have to achieve. You have your weekly reports, weekly performance sheets. Okay. So that is something which is end-to-end support, for placement, end-to-end preparation for placement. And that is what the name says, prep to placement. We will talk about the detail of this program tomorrow as well, because tomorrow will be very clear, with who the winners are, and for this particular program, for other, for other things as well. Yeah. So finally, just talking about the products that we have for you. So eventually, this is the first free product that we have for you, the expert communication, which will help you understand, what exactly should you do next in your life. Eventually, that is what the agenda of our session, Grad Explore, is, which if you have not registered for, you can attend. You can register for the very same on Dare to Compete platform. But if you want a one-to-one, personalized counseling with MBAtrek career advisory team, this is what this is all about. So go to this particular link, mbatrek.com/expert communication. Use this particular coupon code EC100AB. So EC is expert communication. 100 gives you 100% discount, and AB is Aptitude Bootcamp, because that is what you are a part of. Okay. So you can get this product, which is priced currently at rupees 700 at free of cost. The price is not, really very, very important or at all important. What important is you will get a 30-minute one-to-one discussion with the career advisory team. You can ask about your, basic career queries. You don't know what to do next in your life. You are confused between, should I be pursuing MBA or should I be going for a job? Okay, what to do after engineering, you're not really sure. Entrepreneurship, anything, you have this team to help you with that particular thing. Okay, so this is the first product that we are going to give you at free of cost. The second one is interview booster. So a lot of you face problems when it comes to performing in an interview. A lot of you try to run away even from mock interviews, because we think that, we are not really confident, we would be judged, I won't perform good, I will be one of the worst, performers of this entire panel, and so on, so on, so on. Okay. So how can we help you, understand your interview journey without actually taking your interview? That is what this interview booster is all about. The questions in this particular booster, in this particular assessment, will help you understand the different, strategies that you can adopt in terms of answering a particular question, and which one of them is right. Okay. And that will help you, that will help you help yourself, that, okay, this was the strategy which I was using previously. But now, yes, I understand that this is something which I should be doing starting from this point of time. Okay. So this is something which you can check out for free in Interview Booster. Go to this particular link, mbatrek.com/interview booster. Use the coupon code IB100AB. Okay. And you will eventually be able to check out this particular assessment again at free of cost. Again, the cost is not important. The value addition in your career journey is. Okay. So I think we have covered a lot of things in this particular session. We have talked about four, very important things. What I also learned about, maybe tomorrow I'll try to come up with better, approaches and maybe lesser problems in order to deal with all of the remaining portion well in time. Okay, and these are the two products: Expert Communication and Interview Booster, right? Which are there for you right away. Now that is all from my side. Thank you for patience, listening to this particular session, being a part of this particular boot camp till this point of time. Uh, we are open to Q&A. If you have any question which you want to ask, you're totally that is totally okay. We will be here to help you onto that particular thing. If there is nothing that you have to ask, we once again thank you and see you tomorrow once again at at 7 o'clock. Okay, and you will be so the Zoom meeting link is the very same, but the YouTube live link would be again sent to you as part two of this aptitude bootcamp. Okay. So I'm awaiting for the questions. If you have any, feel free to shoot. Meanwhile, I'll just have water because I think I've spoken a lot. Okay. So Shanu, we will have the quiz tomorrow after after the webinar. So what we will do from 7 to maximum 8:30, we will finish the webinar. At 8:30, in the webinar itself, I'll give you the link of the quiz along with the coupon code. Okay. And you will be able to attempt it. Okay. So you have time till tomorrow midnight. No issues. Okay. Yeah. If you have any problem related to aptitude, related to general, career journey or placement preparation, the prep to placement is, by the way, an answer to all of that, but it is going to be launched in the first week of April. So till that point of time, you have us as well in order to help you with all your career doubts. Okay, I'll wait for 1 minute. Okay, and let's see if we have any query. Okay. Sure. So I think I think no one has any doubt, and that is, I think, good for me, because with that, I would want to believe that each and everything that we have covered in this first part of the boot camp has been pretty, good enough for you. Let's hope to see you tomorrow in the very same session, same time. Okay. Thank you, everyone. And yes, you can please exit the meeting, and let's see you tomorrow with more tricks to solve. Yeah. Thank you, everyone.